Hi, everybody. This is part two of the 2.9 applied optimization. So a concert promoter has found that if she sells tickets for $50 each, she could sell 1,200 tickets. But for each $5 she raises the price, 50 less people attend. What price should she sell the tickets at to maximize her revenue? This is a very interesting question because you would think that if you raise the price, you make more money, but on the other hand, you sell more tickets, you sell less tickets, and let's just do some simple calculation here, just to give you an idea of what I'm talking about. If you $50 times 1,200 tickets, that equals wow, it's a lot of money. That's going to be six with a lot of zeros. 6, 1, 2, 3, 4, 60. Wow, $60,000. So good for you. You made 60,000 bucks. Whoops. And if you sell them for $55, then you're not going to sell 1,200 tickets. You're going to sell 1,150. And let's see, what is 55 times 1150? 5 times 1150. So that's 63. So you're gonna make even more money if you do it that way. So if you raise the price, then you make if you charge a measly $50, then you're gonna make 60,000. But if you raise the price $5, you make 63,000. You make more money. Well, this is great, but if you keep on raising if you keep on raising the price, it means you're going to keep on subtracting 50 people, and eventually you're going to get down to zero. I mean, 1,200, 1,150, 1,100, 1,050. Eventually it's going to get down to zero. So obviously the price at a certain point, the price is going to go down. So we want to find the maximum. We want to find that sweet spot where you make the most revenue, because I guess the proceeds are going to go to chat, whatever it is. You want the most revenue for whatever your reasons are. You want the most revenue. Okay, so let's analyze this a little bit here. Let me just take this one statement here. So first thing I want to say is like this. We want to maximize revenue. It says right here, maximize the revenue. And we know that R equals PQ, where P is the price per ticket and Q is the quantity of tickets. So price times quantity, right? Because the price that you charge, I didn't put dollar signs here, but I can. So the price that you charge times the number of tickets that you sell, that's going to be the revenue. Revenue again means how much you bring in. Revenue, by the way, as we're going to see in many problems, it's not the same as profit. With profit is that you have to take the revenue, then subtract the cost, what it costs you to put on this whole concert and promote it and all that other kind of stuff. Anyway, let's so R equals PQ, because so that's what we want to maximize. Green. I'm gonna make green because we're talking about money. This is what we're trying to maximize. So the thing that we're trying to maximize is our objective equation. So this is the objective equation, and I'll put that right there in parentheses. This is the objective. Remember, we talked about the objective and the constraint. That was in the definition we gave previously. Objective. So this is the objective equation. Now we want to figure out the constraint equation. Well, the constraint is going to come from the fact that I get $50 less per ticket. Now, what's interesting here is that we actually have here a sort of a correlation between price and quantity, because every time the price goes up 5, the quantity goes down 50. And if I could think about this as if I was graphing this price versus quantity, you can actually think about what we've done here. Let's take these numbers: 50, comma 1200. That's 1 point on my graph, and then 55, comma blah 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 1150. And this would be like, what I want to do is think of these as being 2 points on a graph, and I want to find the slope of the line that connects these 2 points. Well, I just do, y1. So I just use for slope. So we know that m, this is our famous form, m is equal to y1. Let's make the minus y2. Well, what just happened here? I didn't want that. Well, over x1 minus x2. I just realized I'm gonna x2. Oh, we usually write. It doesn't really matter, but usually write it the other way. Usually put the 2 minus 1. Not that it matters. As long as you're consistent, it doesn't really matter. But let's just finish this. I realize now I'm better off for this part. All right. So what I want to do is it'd be easier at this point for me to write this out by hand. So I'm going to switch cameras. I'm going to write all this stuff out by hand. So here we go. Okay. So we have, so m is going to be equal to 1150. That's y2 minus y1, which is 1200. X2 is 55 minus x1 is 50. This becomes negative 50 over positive 5, which is equal to negative 10. So m is equal to negative 10. And now I can make an equation that connects P and Q, because I had those 2 points and I have the slope connecting them. So I'm going to use the point slope formula. The point slope formula, as you know, is y minus y1 is equal to m times x minus x1. And that means that y minus 1200 is equal to negative 10 times x minus 50. But I'm not using x and y. I actually want to use p and q. So let's just switch that right now. Which is p and which is q? Can you guys figure it out? Which is p and which is q? Which is p the x or is p the y? What do you guys say? Is p the x or is p the y? So you're right. P is the x value because that's the price, and q is y because that's the quantity. So q minus 1200 equals negative 10 times p, the price, minus 50. Okay. And this is going to be this here is my constraint equation. This is my constraint equation. And what I'm gonna do is I'm going to solve for one variable, just like we did before. What I want to do is I want to solve for q in terms of p, q, and then I'm gonna of course substitute that into the other equation. So q is going to be equal to negative 10p plus 500. I'm distributing plus 1200. So q equals negative 10p plus 1700. It's a little sloppy than the plus 1700. There, it's just more legible. Okay, so I'm going to take this. Now, if you remember, we had an equation. R is equal to PQ. Revenue equals PQ. But Q is equal to negative 10P plus 1700. So now we have our big equation and revenue. Now remember, revenue is what we want to maximize. Revenue is now going to be equal to negative 10P squared plus 1700P. That is a beautiful equation right there. Now what I'm going to do now is I'm going to take the derivative to find the we want to find. Well, let's just take the derivative. So R prime is equal to negative 20P plus 1700, and I want to set that equal to 0, and that gives me 20P equals 1700 because I brought it over to the other side. So P equals which comes out to that's 85. So that's my critical value, and but I want to make sure that that's max versus min. Now to me it's very clear and obvious that it's a max, not a min, because this equation for R is really an upside down parabola. Well, let's do this calculus. Okay, so I have a choice, of course. I could take a well, what I'm going to do actually is I'm just going to it's going to be very simple here to take a second derivative. R double prime just equals negative 20, and negative 20 is always a negative number, which means it's concave down, which means I have a max. And that is what I want. So if P is equal to 85, that's going to give us, meaning if I set the price at $85, so a price of 85, big ones will yield maximum revenue. Because it's $85 per ticket, obviously. Let's need to switch counters for a second. Okay. Oops, I want to share my screen again. Well, you're probably dying to know what's going to happen when she sells those 85 tickets. What's going to happen here is that the promoter is going to sell by charging $85 a ticket. Then Q is going to be 1700 minus 10 times P, or 10 times 85, and it's going to be 850 tickets. So $85 is going to wind up being 850 tickets, and they're going to start making $72,250, which is more than 60,000 and more than 63,000. But if you would continue, you're going to start losing money. And that's the way it is. So that's pretty awesome. That's pretty awesome. Let's carry on. Actually, you know what? I'm going to end this video, and I'm gonna do more in the next video. So let's stop the madness right now, and bye everybody.